Hello CTM students, welcome to the lesson for 13.5, and I thought I'd just stop by, say hi. It's been a little while, haven't brought out the webcam in a while, that's all. Alright, moving on to some vocabulary. We've got all these different things, a lot of these words I bet you know of from prior math classes, but average, measures of central tendency, arithmetic means. There's something called a geometric mean that you learn about in geometry, and you learn about some other classes too. But we're going to talk about the arithmetic mean. Whenever we say mean, that's what we mean. That is what we're referring to, the arithmetic mean, unless you are told otherwise. And then the rest of these words as you see there. So make sure you're using those extra examples in your book. I'm going to do a couple together that's going to kind of combine together what the book splits into several different examples. But we need to start off, I feel, with this lesson by defining quite a few things. And so let's start off with some definitions. So what are averages? Let's come to a consensus on what constitutes an average, and I want to put after this also known as, aka, measures of central tendency. Hey, that's what this lesson's about. What do you know? Okay. So averages are measures of central tendency. These are, let's underline that too, these are a couple vocabulary terms right there, so I'm going to underline those things there. These are numbers that are representative of a group of data. And then e.g., for example, that's a little Latin phrase there, e.g. I don't remember what the E and the G stand for, but it just means for example in Latin. So mean, median, mode, and mid-range. So technically all four of these things are types of averages, quote unquote. Generally though, when we use the word average, we tend to think of the mean or the arithmetic mean. Let's define that next. What is the mean or the arithmetic mean? So I'm going to put arithmetic in parentheses before it. There is something called a geometric mean. There might be other kinds of means that I'm not even aware of, but I know of arithmetic and geometric means. So the arithmetic mean, or just the mean, is more what we're referring to here. What is the mean? The mean is, sometimes you see it like this with an X with a bar above it. So if you ever see that, that's the mean of a particular set of data that you're looking at. If you want to do the mean of the whole population, this is just totally something off to the side, don't write this down, but the mean of a whole population is this Greek letter mu, I believe it is. Let me double check that. Yes, that is correct. So this Greek letter mu would be the actual mean of the entire population. If you could find like the average age of every single person in the United States, and you found that out, without a doubt, you got the age of every single person, and you would do that. But if you were doing a sample set of the data, you would use something like this. So generally in this class we'll use this for the mean, the X bar, instead of the mu. And X bar is equal to, and I want you to learn a new term here, potentially learning a new term. Some of you may recognize that from a different math class, but a lot of you might not. Algebra 2, we talk about this, and when you talk about sequences and series. But let's define what these things stand for. So I think most of you probably would say, well, the mean, you just add up all the numbers and then divide by how many numbers there are. That's exactly what this means. This is what that stands for. So this right here is the sum. This little symbol right here, this kind of weird looking E, that is a symbol in math to say the sum of, and then whatever is after it, the sum of all that stuff. And so this X represents the data. The sum of all the data is another way to say that. So this is the sum of the data. Notice different color here. Please use a different color for the things that I do in different colors on this set of notes here. And then this number, N, represents the number of pieces of data. It's the number of numbers that there are. So number of pieces of data. That is what the N stands for. Okay, so just like you probably were thinking, it's the sum of all the numbers divided by how many numbers there are. That's another way to say the same thing. Median. How do you find the median? So to find the median, you're going to put the values in order first and then find the middle number. So it's the value in the middle of a set of ordered data. That's key, that is critical. It's not just the data in any old random order, but it's ordered data. Another way to say that would be ranked data. That's what our book uses, but I liked ordered better, so I use that. Alright, mode. What is mode? Mode, think of what shows up the most. They kind of sound the same to me. Mode, most. Median, think of middle. Mode, think of most. Mean, think of averages. Think of average. That's generally the word that I'll use for this. I know, yes, averages we can say are these four things, but generally when we say the word average, we're going to be referring to the mean. So the mode is the number that shows up the most, or the piece of data that shows up the most. Another fancier way to say that, it's the piece of data that occurs most frequently. Piece of data that occurs most frequently. Fancy schmancy. So most. I want you to think of middle when you hear median. Mode, most. And there's a couple more things I want to define here still. We've got mid-range. Actually, three more things. Mid-range. What is the mid-range? This was a new one for me. I hadn't heard of mid-range before I read this book, but it's actually pretty easy. You're just going to take the lowest value. I'm going to put an equal sign here because this is what it equals. It's the lowest value plus the highest value. This is in whatever set of data you're looking at. It's all that divided by 2. So it's in the middle of the range. The range of values would be from lowest to highest. It's the midpoint of that range of data. Take the lowest, highest, divide it by 2. And then two other things, percentiles and quartiles. What are those? There are, I'm going to just put this in the context of a sentence to make it easier to understand rather than try to define it like I had up here within the sentence. I think this makes more sense. So there are 99 percentiles. Dividing a set of data into 100 equal parts. And to me this makes complete sense to call it a percentile, because when you think of percent, you're thinking per 100. So per 100, there goes my door squeaking. If that hey, if that went through there, could you hear that? I don't know. Could you hear that? It sound, oh my gosh, that sounds spooky. No, don't worry about it. My heater just turned on and it changed the pressure within the room and it opened the doors up a little bit. Ooh. Okay, there are 99 percentiles dividing a set of data into 100 equal parts. So 100 parts, 100%. These 99 percentiles will divide it into that. And if you, we're not going to talk about this too much within the context of the examples, but if you scored in the 98th percentile, that means 98 of the population scored lower than you, 98%, and 2% scored higher than you. You can kind of think of it like that. If you were in the 56th percentile, 56 are below you, 56%, and 44, the remainder, would be above you. So there's 99 percentiles. And when you hear the word quarter, I think of 4 things. When you hear the word quartile, think of a similar type of thing. So there are 3 quartiles. And you say, well, 3, that doesn't make any sense. You just said 4. What do they divide, though? 3 quartiles dividing a set of data into 4 equal parts. There we go. So 100 equal parts percent per 100. Quartiles per quarter. So 4 equal parts. And then one more thing off to the side, I want you to do this in a different color too. So these two things, these were all measures of central tendency. These two things, percentiles, quartiles, these are more measures of position. So that is also one more thing that gets defined here. These are more measures of position. Positional values, in other words. Okay, let's get into the examples. Let's check out some examples here. Just going to do a couple examples, and we're going to find several different pieces of information with each set of data that we look at, with both sets of data that we look at. So first of all, example 1, determine the mean, median, mode, mid-range. I wonder if they did that on purpose. They all start with M. They're all these middle values, sort of, or these average values. Mid-range, Q1. Q1 stands for quartile 1, in case that's new to you. Q1 and Q3, quartile 3. Q2 is actually the same thing as the median, because Q2 would be halfway in between. There's the 4 separate, or the 3 quartiles separated into 4 equal parts. Q2 would divide it into 2 parts. So the median you can think of as Q2. So in Q3, for the following set of data. For the following set of data. Okay, so here's our set of data. I'm just going to write it in a string, leave space in between each number. So 3, 5, 16, 3 again, 15, 13, and 8. There are going to be 7 values in this set of data. So let's start off with what I put first here, mean. What is the mean for this set of data? So here's my solution down here. Solution for the mean, how do we find this? We're going to, just like we had said back here, go back to your definitions if you forgot. You're going to add it all up, sum of the data, divided by how many pieces of data there are. There are 7 pieces of data, and you're going to add these numbers all up. So remember, it's the same thing as saying x bar. That's the same thing as saying the sum of all the data values divided by the number of values there are. I just want to get a little more practice writing that little summation symbol. That's going to be important as you move on in math, if you continue in math from here, and as we talk about the rest of this chapter too. So adding all these things up, dividing by the number of numbers there are 7, and if you add all this up, I double checked this was 90, no it wasn't, it was 63. This was 63. You can double check me if I'm wrong, you tell me, and I'd get you some bonus points if I was wrong. If you ever catch a mistake again, just write those things down, write the time you see it. Help me out make these videos the best they can be. 63 over 7 ends up being 9. So the mean, the arithmetic mean, in other words, or generally we'll say that's the same thing as saying the average value is 9. How about the median? We're supposed to do what first? We're supposed to put them in order. So if you didn't put them in order, and then you would look at the middle number, you would say 3 is the middle number. 3, though, clearly is not representing the middle of this set of data. So we first need to put it in order. The median, let's write that down as a reminder to ourselves later what we were doing. So put in order first. Got to make sure we do that. That's supposed to be an exclamation point. Or a factorial. But no, that's exclamation point. And then put it in order. So 3 shows up, and then 3 shows up again. So I got to write it down twice. 5 shows up, 8 shows up, going in order, 13, 15, and 16. This one was easy enough just to pick them all out, but you may want to cross them off one at a time if your set of data is bigger than that to make sure you don't miss any. Okay, now what's the middle number in this set of data? I hope that's clear that that's going to be 8 right there. How can you tell for sure? Well, there's 3 numbers below it and there's 3 numbers above it. As long as those 2 numbers are the same, 3 numbers here, 3 numbers here, whatever here, as long as the whatever is the same both ways, then you're good to go. So let's put a little note in a different color here why this worked out, or why this was the median. There were 3 below and there were 3 above. That number doesn't always have to be 3 below and 3 above. If you had a list of 9 pieces of data, you would have 4 below and 4 above. If you had a list of 13, you would have 6 below and 6 above. If you have an even number of pieces of data, we're going to talk about that in the next example. That one's a little bit trickier, slightly trickier, but it's pretty easy still. Mode. What shows up the most? 3 does. 3 shows up twice. After you put it in order, it's even easier to tell that that's the mode. 3 is going to be the mode. So 3, why? Because it shows up most. The mid-range, you just take the first and the last value in your ordered set of data, that would be the lowest and the highest, add them together, and divide by 2. So we have 19 over 2, which is the same as 9.5. So that was easy. I need that Staples button right now. That was easy. Alright, Q1. I'm not going to say it equals something yet. How can I find quartile 1? This one takes a little more thinking through, but how do I find the middle, in other words, of the first half of the data? That's what I'm essentially saying by saying to find quartile 1. So where's the first half of the data? Well, it would be this stuff. Do I include this value? No, because it's exactly 50% of the way. So because it's exactly halfway, I'm going to take the things that are less than halfway. So I'm going to take those 3 values, 3, 3, and 5, and find the middle value of that, find the quartile 1 or Q1. So let's write that down. We're going to take all values below the median and the median, don't forget, is the same as Q2. So if you ever see Q2, don't get confused. That just means the median. Those are the same values. And find the middle value. So that set of data would be 3, 3, and 5. The middle value there clearly is 3. For quartile 3, the same sort of thing now, except for the other part. This is 25% of the way. This is going to be 75% of the way with the listed data. And so we're going to take all values now above the median. And find the middle value. And so that would be, writing it down, 13, 15, and 16. The middle value is 15. And that does it for example 1. Let's check out one more example. This one we're going to have a couple of new twists. That's why I wanted to do one more example here to talk about how those new twists might work. So determine, again, the mean, median, mode, mid-range, Q1, and Q3. I'm going to leave out for the following set of data. I think that's pretty clear that that's what we're doing here. So let's write down the values. I'm going to have 10 values on this one, 10 pieces of data. 9, 8, 13, 4, 8, 18, 9, 7, 3, and 12. And this data, I just made up some numbers. I'm not really very interesting, I guess, with where I'm coming with these numbers from this lesson. but I just wanted to use numbers that were easy to use to start as we start to get the grasp of how this works, and then later on we'll actually look at real life things and find more interesting things about real life things rather than just random numbers. So the mean, again, that's X bar. Just want you to get a little extra practice to just ingrain that into your mind. The mean is the same as that. It's the same as that, which would be, you add up all these numbers. Let's write that down. 9 plus 8 plus 13 plus 4 plus 8 plus 18 plus 9 plus 7 plus 3 and plus 12. And again, please double check me on this, but I've done the math. I've double checked. I'm pretty darn sure that I got this. 91 over 10. You're dividing by 10, you're moving the decimal one spot. That would be the same as 9.1. And so that's the mean. You can have decimals for the mean. You can have decimals for the median. You can have decimals for pretty much all of these. If you had decimal values within the data, you would just add the decimals up and do that. Median, again, we need to put them in order first. So put in order first. Got to do that first. Otherwise, you would be tempted to say that the median would be in between these two numbers, and that is not necessarily the case. So let's put them in order first. 3. And then what comes next? I'm going to cross them off as I go here. So 3. And then 4. Notice a slightly larger list of numbers. Easier to leave one out if you're not crossing off one at a time. Next would be 7, it looks like. And then I've got 2 8s. So I'm going to put 8 twice. And then I have 2 9s. I'm going to put 9 twice. 9 and 9. And then I have a 12, a 13, and an 18. 12, 13, and 18. Okay, so that is done now. Now I'm going to refer to this as my set of data because it's easier to think about what's highest, what's lowest, what's in the middle, etc. from there. So I've rewritten my set of data. It's still the same values. What's the middle number here? Well, it looks like there's 10 values. So if I went in between 5 and 6, that would be where I'd want to go, but there's no number here. I've got this even number of values, even number of pieces of data. And so what I need to do is to think about this. I want you to circle these two numbers in a different color. So circle these two in a different color. From there, there's 4 below and there's 4 above those two values put together. Let's write that down in our different colors. So there's 4 below, 4 below, there's 4 above. And so let's bring down an arrow here. So what's the median? Is it 8 or is it 9 or is it neither one? It's neither one actually. What do? You just find halfway in between those two middle numbers. And so you're going to take 8 plus 9 divided by 2. You would have 8 plus 9 is 17 divided by 2 would be 8.5. So 8.5, that does not look very good at all. Let me make that a little clearer. 8.5, that's better, is the median because it's halfway between B/W for between the two middle numbers. So if there's an even number of numbers, the median will always be halfway in between the two middle numbers. If there's an odd number of values, then it's always going to be that middle number. There'll just be 1 if there's an odd number of values. Halfway between the two middle numbers. So it's the median. So we got mean, got median. What's the mode next? The mode, in this case, there's 2 8s and there's 2 9s. And if there were 3 of one of those, that would be the mode, but there's 2 of each, and then there's just 1 of the rest of them. So what is the mode? The mode is both 8 and 9. At least that's what we're saying for the purposes of this class. Some books would tell you that there's no mode because there's no value that shows up the most, even though there's kind of this shared majority, you might say. But 8 and 9 for our book, for purposes of our book, we're going to say that if there's a tie, they both win. They're both the mode. So 8 and 9, both. Looks like I'm running into some trouble here. There we go. Both show up twice. They don't have to show up twice. It's whatever shows up the most. The number could show up 3 times. Thrice. Ooh, nice word, Mr. Wagner. I got you. I got you. Thrice. That's a real word. Look it up if you're going to disagree with me. Look it up. It's real. I don't think there's a special word for 4 times though, but you could prove me wrong. Let me know if you come up with a word for 4 times. We'll show it up twice. So they are both the mode. And just segregating that so we know what went with what. This is called, if you see that, there was one more vocabulary word that we didn't get to yet. That's called bimodal. So just like bicycle, 2 wheels on a bicycle, you've got 2 modes if something's bimodal. Alright, mid-range. That one's real easy. Find the first, find the last, add them up, find halfway in between, divide by 2. So you got 21 over 2, which is 10.5. And then Q1 and Q3, I don't feel like we have to write down the same thing we did here again. We should have an idea. Now we're taking all the values below the median and finding the middle value. So we're doing that here. It's 3, 4, 7, 8, and then a little bit of a conundrum here. Do I count this 8 as well? Well, this was not exactly halfway, so it would still be below 50%, this 8. So yes, you're going to count that extra one there. So halfway would be, boom, right here. Over here, though, halfway was exactly through the 8. So if it gets kind of slashed through, you can think of that. If it gets slashed through, you're not going to count it as part of your quartiles. But if it doesn't get slashed through, like right here, the slash would split it up evenly. It would still be not slashed through. It would still be part of the first 50% of the data. So it's below that. It is below the exact 50% mark. Therefore, 7 is going to be your Q1. Q3, do the same sort of thing, now just with the second half, the latter half of the data. 9, 9, 12, 13, and 18. Q3 is going to be 12. 1 more, 2 more, same thing, but same sort of note. Let's write this down in a different color. Why exactly this was, there are, so we already said this, but there are 5. Now I want to say that, there are 5 pieces, that's fine, I can say it like that. There are 5 pieces of data below the median in this case. This 8 was still below the median, 8.5 being the median. And one more thing in a different color here, there are 5 pieces of data above the median. That's why we included the extra 9 right here. That's still above the median. Above the median. Okay. And I feel after that you should have a really good grasp of the material at hand. We will practice some more of these later together in the classwork that we were doing. Might even have an activity to go along this one. We'll see if we have something like that. But beyond that, rewind, review, and ask me questions as needed. Alright, thanks guys, and have a wonderful morning, afternoon, evening, whatever, whenever you're watching this. I will catch you later.